Hello, stat students. Coming to you from the comforts of my backyard, hoping the birds chirping in the background will add some, um, maybe some inspiration here as you hear a little recap of our first unit of the year, which was sampling and experimental design. At least at this point is our first unit. Um, I'm just going to go through our note sheet, which is mainly terms from this unit. Again, sampling and experimental design. There's a lot of um, really not many numbers at all that show up in that unit or in this unit that it's more about terminology and understanding when you set up a sample how it should be set up properly, and when you run an experiment how an experiment should be run. So first of all, in designing samples, again, the idea around all of that in designing samples in the long run is this notion of um, trying to create a statistical inference problem. Um, and statistical inference is the idea of eventually running a statistical test on this. We run t-tests, we run proportion z-tests, we run chi-square tests. Those are all ways that we eventually put these samples to use in terms of statistical inference, which is really just trying to use the data to answer specific questions about the data with a certain kind of comfort and statistical backing in terms of the meaning of the results. So when we collect a sample, first thing we need to do is identify the population. Okay, is the population going to be all U.S. citizens, or is it going to be Minnetonka high school students who are 18 years old, who cross Highway 7 and on their way to school, and who have been to Target in the last month? Okay, so population is defined very specifically um, by really who do we want the data to be generalized to. Once we have established our population, it is from there where we collect our sample. Okay, and so collecting your sample, um, this is the notion that you've got this bucket basically of people or items or whatever it happens to be. Your population doesn't necessarily have to be living beings. Your population could be all cars that have driven on 101 in the last 3 days. But you take your population, that's your bucket. From that, you select a sample. And a sample, again, is just a subset of the bigger group. And we do this because we don't want to have to deal with a huge sample. We'd rather deal with a controlled size, a huge population. We'd rather deal with a controlled size sample, whether that be 30 or 50 or 100 or 200. It's just going to be easier to work with than a population. Now, when we select that sample, we want to be very, very particular in how we select it, and that's where the validity in our results comes. So a simple random sample here is probably the most common type of sample we hear. This is oftentimes referred to as an SRS. And a simple random sample simply means that every possible combination of whatever size we want, so let's say our sample is 50, every possible combination of 50 items has the exact same chance of being selected. So that's what this is right here. All samples of size N or size 50 have the same chance of being selected. So that could be the 50 who were selected, or you could take one out and replace it with every other individual through the population one by one to be the 50th person if it's people to select your sample. So a simple random sample, the most common way that we hear for a simple random sample is simply you put all the names, or you number everybody. So you label everybody, whether it's cars or people or whatever it happens to be. You put them all in a hat, for instance. You mix up the hat, and they require you to say you mix it up on the AP exam. You mix it up, and then you select out one by one however many you need for your sample. So that might be, in this case, we said 50. So again, if we have 3,400 students at Minnetonka, every student gets a label on an equal size sheet of paper. And that label has their full name or their student ID number or whatever it happens to be. Maybe we numbered of 1 to 3,400, but we talk about how we label them. We mix those up, and then we pull out one at a time until we have 50. We don't pull out 50 at once. That's a little different. And we'll get to that momentarily, but we pull out one at a time until we get to 50. That's a simple random sample. Probability sample here just means everybody has a chance to be selected. Okay, so a probability sample is a simple random sample is an example of a probability sample where everyone in our population, every item, whether it's a person or a car or whatever else, has at least a non-zero chance of being selected. That might be 1 in a billion, or it might be 1 in 10, but they have a chance of being selected. Stratified random sample is uh, a sample where we take our population and we first divide it into subgroups. So again, if this is our school, we would take maybe a bucket for all 4 grades, 9, 10, 11, 12, and then we'd select maybe 25 from each one of those, and that would be our sample then of 100. Okay. And the reason we use a stratified sample is we simply would want a sample that has a fair representation from different subgroups. And it could be equal representation or it could be just proportional representation. So for instance, if there were 800 seniors but only 400 juniors, you might have twice as many seniors in your sample as you have juniors. Or you could keep it at 25 each. That's your choice. It depends what you want to accomplish in your data collection. Um, but that's the stratified sample is about having representation from all the subgroups, and you really want that if the subgroups have uh, different characteristics. So if you have a question where a ninth grader might answer it differently than a senior, then you really want to make sure that you try and have them equally represented if you really want a cross section of the high school, so that in your sample of 100 you don't have 90 seniors and 2 freshmen, which could happen, of course, in a simple random sample. Okay, next one here, multi-stage sample design. This one's much more rare, and this is kind of a zooming in on Google Earth, for instance, where you randomly pick some, if the population is Minnesota, you'd randomly pick some counties, and then within those counties, you'd randomly pick some towns or cities, and then within those towns or cities, you'd randomly pick some blocks or streets or whatever, and then you'd randomly pick some houses on there. So it's like you're zooming in one by one, but all randomly. That, like I said, very rare. Cluster sample, this is a little more common, but not nearly as common as a stratified or a simple random sample. But cluster is where you would, it'd still be random clusters, but you would select 25 at a time. So when you put your hand in the bucket, you are selecting 25 names or 50 names in one shot rather than picking them one by one. The most common cluster random sample situation would be like if you worked on an assembly line and let's say you were making iPhones and you wanted to check and make sure the iPhones were working properly, you might every hour randomly pick one box of 25 iPhones and pull that whole box off of the line and test those out. A little quality control check. And that again is it would be all one uh, one selection, but the sample would be 25 because you pick 25 at a time, but you never pick one at a time. You're always picking in groups. Advantage of this, of course, is you can get a big sample really quickly. um, but the disadvantage would be that you are, for instance, in the iPhone situation, the if one of them doesn't work, they might all not work, and you didn't really get a true cross section of the iPhones that were made. You just got one box rather than 25 iPhones from different times of the day or something like that. So that's what you get out of the cluster sample. Really quick, but you lose some of that individuality in your sample. There might be the group might be alike in some way that makes them not completely random. All of this, in terms of your sample design, all of it is an effort to control bias, which means basically you just want to be fair. You don't want to have your sample systematically favor a certain group or item or whatever it may be. Um, and that can come about if you get your sample in some easier but less random ways. And one of those is a voluntary response. Voluntary response is probably the most common sample selection because it's easy. And voluntary response would be like if you put a question on a website or on the TV and just ask people to call in, or to fill out something on a website with their opinion. And the problem is if you have a spectrum of opinions, and this is neutral in the middle here, and this is really for something and this is really against something, what you're going to get here is your responses are going to be people who are really out here or really out here, really for or really against an idea. And so you aren't getting really the neutral observers and you're getting strong opinions. So that's the big thing with voluntary response. Non-response is simply people refusing to cooperate. Um, so if it's something where there's telemarketing in place and they're calling houses and people are just hanging up on them, that would be non-response. Sometimes it's just because you don't want to be a part of it. Sometimes the question is sensitive, and so you don't want to answer it. But non-response would be just basically not responding to the question or to the activity or whatever it happens to be. Confounding variables are where you really are trying to isolate um, something as a cause-effect relationship. People don't like something because of this, but the confounding variables might be other reasons they don't like it. So if you don't like uh, the summer because it's hot, but you might also not like the summer because it's humid. Humid would be a confounding variable if you just said summer is too hot. Well, it's that it's too hot and it's too humid. Maybe it's mosquitoes. Maybe it's that you like cold weather, whatever all these other reasons are for confounding variables. The most common one that we see with confounding variables is like rationale behind good or bad test scores. And people in education will try and isolate and say good or bad test scores are a result of socioeconomic status. Well, um, that might be an indicator, or it might contribute one way or the other, but there are also other reasons for good or bad test scores that confound with that, and that might be preparation or background, how important education is in your home, things like that. So those would all be confounding variables or other variables that could influence our results. A couple other here on sampling. Convenient sample is just the idea of you're just getting to people who are really easy to get to. And so you're uh, like in school, if you're asking students to answer a question for a survey, you might just go into the Commons and just go to the first 20 people you see. That would be convenient sample. Undercoverage is a big one. Undercoverage is the idea that not everybody in your population had a chance to be selected to be in the sample. So again, this flies in the face of the idea of a probability sample. Okay, undercoverage is not about sample size. Okay, you could have a sample size of 20 that has no undercoverage and a sample size of 20,000 that does undercover. Okay, so it's not about sample size. Um, Undercoverage is simply about, was there somebody in your population who had a 0% chance of being selected? That would be undercoverage, because then that person, the person's opinions did not have a chance to be included. Undercoverage in reality happens more often if people just intentionally don't ask a certain group of people because they know they have certain opinions or something like that, or they don't include certain types of cars in a study of cars because they're really good or really bad or whatever it happens to be. Undercoverage would happen a lot like in politics if they wanted to make sure that the sample didn't represent certain political beliefs, and so they instead of having the population be all American voters, it might be they might say it's all American voters, but really only gave folks who had certain opinions a chance to be selected. Last one we'll talk about in this video is response bias. Response bias is just your lying, or your telescoping events. This might be in a court case where you said something happened 3 months ago and it really happened 4 months ago, and that ends up being important, but you didn't even really realize it, that it was 4 instead of 3 months. So it might be an accident, or it might be just that you were asked a sensitive question. For instance, if a high schooler gets asked straight up about their alcohol consumption or something like that, they might just not be honest, or just be uncomfortable being honest because they were asked in a kind of an unfair situation where they shouldn't have had to answer. So response bias is lying, or this telescoping is that idea of, oops, sorry, telescoping is the idea of saying, that it was 4 months ago instead of 3 months ago. So that's the sampling part of this first unit. I'll leave it at that since this video is already at 14 minutes. We'll come back in the second video about experiments.